Welcome to Study Loop.
So we're given the adiabatic pressure of the given gas, and here we will start from the first law of thermodynamics, and also we will use the condition that when we have adiabatic compressions, the heat absorbed is zero, so Q will equal zero for all adiabatic processes. That is their specific property. Now, this implies that in that case, change in internal energy of the system will be equal to the negative sign of the work done by the system or on the system. Now, we need to evaluate the work done in this specific problem. For this, we will use the already derived formula for the work in case of adiabatic processes that is given in the textbook. This is the equation 1926 in the textbook. So the work done is 1 over gamma minus 1 P1 V1, and then we have 1 minus, and then the ratio of the volumes, gamma minus 1. Also, since we have this ratio right here, we need to relate this ratio to the pressure ratio, which can be done using also a textbook formula for the adiabatic process pressure relations to the volume. This will be that the pressure ratio between the final and the initial pressure is going to be equal to the ratio of the initial to the final volume on the factor gamma. We know that this factor is, for this problem, gamma equals 7 over 5. We can substitute that and find that the final pressure is initial pressure times the ratio of the volumes on 7 over 5. Substituting the rest of the known values, we see that 1.22 times 10 to the 5th power pascals times 3 on 1.4, and this equals to 5.68 times 10 to the 5th power pascals. Obviously, we need this pressure in order to evaluate the work done. This is why we did all of these calculations. So back to the work equation or function, we can evaluate the work done. We will simply rewrite it here. So this is going to be 1 over, this is going to be 1 over gamma minus 1 P1 V1, 1 minus the ratio of the volumes, gamma minus 1. And here we can simply substitute all of the known values. So this is going to be 1 over. We know that 1.4 minus 1 is 0.4, so that can be immediately substituted, and the rest we can relate now these volumes and ratios. So the volumes to the pressures from the previous evaluations, from the previous equation. So this will be square brackets 5.68. Obviously, this is the final pressure, pascals, times 10 times 10 minus third meters cubed. This is the volume. And then the initial pressure, this is 1.22 times 10 to the 5th power pascals. And this will go times 30 times 10 to the minus third meters cubed, and we're closing the square brackets. Therefore, the work done, when we will place all of these values into a calculator and immediately evaluate it to be minus 5.10 to the third power joules. This is the work done. Now remember that the work and internal energy are related like this. So from here we can finally say that the change in internal energy for this adiabatic process is going to be 5 times 10 to the third power joules. And as we can see, delta U is positive, which means that the temperature will increase, because always delta U is directly proportional to delta T. If delta U increases, delta T increases. There is an increase in the temperature in this process. This is also a characteristic of adiabatic processes. I hope this was helpful, and I hope to see you in the next lesson. Bye.